This presentation is about using time-based one-time password. And basically what it is about something called two-factor authentication. Is somebody familiar with two-factor authentication, already using it? Somebody already using it in their own app? Yeah. Cool. What kind of method do you use? Okay, thank you, good point. Okay, what is it about? We are more and more delivering applications over the web. And if you deliver an application over the web, you want to make sure that only people who are allowed to go into your web application can go in. Just securing that with a user ID password might not be enough. If somebody gets to guess your user ID password, they basically have access to your application and they could do bad things with it, or maybe get information from it. So that's something that you don't want to. So what you see more and more, I just upgraded my Apple to the Apple iPhone to the latest software, and they use two-factor authentication. Before I could include or install the update, it sent me a code by SMS. I had to type in a code, things like that. You need to be sure that the guy who's logging into your system is really the guy who's logging into your system. And you can do that using a two-factor authentication. So you want to identify the party. Passwords, of course, should have been kept a secret. Because what happens if somebody gets access to your password, for example, to your, maybe even to your email password? I think that the password to your email is a very important password, because most of the time, if you cannot get into the system, what they allow you to do is type in something and say, okay, please email me a reset function, for example. So even if you're just using email, I would recommend using some kind of two-factor authentication on your system, because if you don't do that on your email, chances are they can get access indirectly to any system you're using where you registered with that email address. So be very careful with that. And all the public email systems like Google, Microsoft, etc., they all allow you to install two-factor authentication. It's not hard, just do it, and then you'll be much safer then. So two-factor authentication is based on this fact. It's something you know and something you have. Something you know means you know your user ID and you know the password. There are things you know, even without happening anything, you would be able to log in. And it's based on something you have. Something you have could be a phone. I think that's the most appropriate device. It could send something to your phone. But you also can have different codes. For example, a little key that displays a code. But those are the principles. Something you know and something you have. If you have both those two things, then you get access to such a system. So what do you use it for? Well, any of those guys, they use all two-factor authentication. It's not on by default. Well, I think it's growing into that direction. But currently, if you use one of those systems, you can apply and say, okay, I want to use two-factor authentication, register the code with your Authenticator app that you have on a phone, and you're good to go. So what does it do, a two-factor authentication? And specifically this one, the time-based one-time password, TOTP. It's a standard. If you look it up on the internet, you will find a wiki about it, and it's applied to the Internet Engineering Task Force. Sorry. Basically what it does, it takes some secret that you have, and it takes the current time, and based on those two kinds of information, it will generate a code. Most of the time, that code will be a 6-digit code. And that 6-digit code could be generated by your app, or it could also be sent to you in an SMS message, or you could even send it to someone in an email, for example. But it basically means you have to have access to all of these systems in order to be able to generate that code. What it also does is the time is taken, and it's taking the time in periods of 30 seconds. So every 30 seconds, it will generate a new code. So even if somebody gets to get access to this code that has been generated, it will only last for 30 seconds. After those 30 seconds, that code will not be valid anymore, and it will generate a new code. Yeah, that's the way it works. If you look at this picture, this is just a sample of showing what actually is being doing. Basically, this should be the sender and the receiver. The receiver can be your application. So your application has something, and the sender, this could be the iPhone app or the whatever phone you have, the Authenticator app. Basically what they have to do is they have to have the same, what in this type is called message. Let's call it a secret. And the secret usually is a 32-bit, 32 character, you should say, wide string. And what both apps do is they will get it through an algorithm, the message authentication code, and it will generate a code here. What it does with the time-based password, it will also add not only the message, but also the time. I didn't draw it here, but there's also the current time goes into that, and it will generate a code. You send that code to the server. The server does the same thing. Both have to know the message, the secret. Both know what the time is. So this one will also do the same calculation. And then basically what it will do is compare the two. If they are equal, then what your server can do is say, okay, I get the same code here, so they probably know the secret, so the code is okay. That's basically how it works. Different kinds of generators. You could have an SMS message, like a token device. Like this one is an RSA Generator. Some of you might know these devices. Those generate the same type of code. It's a similar thing as with using the app. It's a standard. This one will every 30 seconds just generate a new code, and you can use that in your application. Somebody of you have those devices, or? Yeah?
A customer that requires the use of it.
Yeah.
And I think the secret on it is actually the MAC number of the hard disk drive.
Right.
Or something like that. I can't.
Yeah, you have to.
I could use it here. It wouldn't work here.
Yeah, this device has some secret installed. It can be a password. Of course, the system that you're connecting to needs to have the exact same password. Otherwise, they always will be off. So you have to register it once, and then it will work. Most banking applications use some kind of these form of generating codes, etc. Okay. Client-side Authenticator Apps. My favorite is Google Authenticator to use it. It's just a free version. You can just download it and install it on your machine. Microsoft also has the Authenticator app. You get Authy. This is a third party. You probably can find another dozen of those apps that you can just install. And most of these apps, you can have multiple codes. So what it looks like, let's see if I can switch. All right. This is my phone. Hey, Henry, what are we going to do? Food? Oh, cool. Okay. Can you see it? Yeah. So I have this Authenticator app. It's on the right side. So if I click it, what you will see are my codes. So if you would have to know my password, this information would allow you to go into my system. I'm happy that you don't know my password because this is all the information. But this is what an Authenticator app does. So it generates codes. You see them becoming red now. This means that I'm about to enter the end of the 30 seconds. You see this little time thing here, this hourglass. So within 30 seconds, it will just pass by and will generate new codes. So how do you get a new code in here? I'm clicking on the plus at the top, and it says, okay, I can either scan a barcode here, or I can do it manually, enter the secret. Usually you would enter or scan this barcode, so you just click it and we'll bring up the camera, and you have to scan for a code. Okay, let's go back. This one. Yeah. So on the client side, you need a generator that takes the time, takes the secret, and combines that into a new code. This is the code that it's generating. If you type in that code on the server and you're giving that to your login dialog on the server, you would have to do the same thing. So somebody adds it there. And then what you do on the server side is you do the same thing. You take the time, take the secret, compute the code, compare the both. If they're equal, you allow access. If they're not equal, you deny access. Basically, that's how it works. But what if you have different time? So, for example, the time on my phone is not equal to the time of the server. If you're off by 30 seconds, you would never get in, right? So usually what you do on a server is you calculate not one code, but you calculate also the code for the next time and the code for the previous period. And you can extend that. You can also say, okay, I'll leave it for 2 minutes or 10 minutes or whatever you like, so that you allow for a little time delay or time ahead for the device that you're using. And once you do that, you just say, okay, does it compare with for time 0? No. Try +1, -1. No. Try +2, -2. Wherever you want to stop, you say, okay, this is the time frame that I'm still allowing people to log into. Okay. So what does that look like? Let's see. My mouse. This is the app. I'm running it. This is using normal DataFlex standard style, but it has an extra code here. It says login name, password, and it has the code there where you can enter the code. So login would be guest, guest, and if I do sign in, it says, okay, invalid combination of login name, password, and code. All the three of them need to be equal. If I want to log in using the phone, I can use the phone and look up the code. Let me try to switch. A lot of things to take care of here. The DataFlex code should probably be 065168. Let's go back. And I'm showing the code here. And you see it's the same code here. This is the code, current code, that you normally would never put out on the website. This is just a demo purpose, of course. But this just shows, okay, what is the current code that you would have to type in. So what I can do is now type in this code, 0656186, and I'll sign in. And that will allow me to go in. So it's only that combination will allow. If I try it, I log out again. Log out. You see that the code now changed because we just went into another time of out period. So the code would be valid. Somebody can remember the code? Yes. 056186? Okay. So that still should allow me to go in. Yes. So you see, I can still get in with the previous code because I allow it for it to be 2 off on the plus and 2 off to on the minus sign. Okay. Let's go back here to the presentation. Okay. How is it implemented? It's implemented with a class, the C one-time password class, and it uses a DLL. This DLL has been written by Ulbus Tellema. He's one of our colleagues in the Netherlands. And why did he do that? Because for calculating the code, you need to apply a bit of logic. And it also involved using XOR and ANDs and also bit shifting, etc. If you ever try to do that in DataFlex, it can be done, but it's complicated. So we said, okay, let's create a DLL that does those functions for us, and then we simply call that DLL, and it will do the calculation of the codes so we can compare them easily. We also needed functions for base 16 and base 32 encode. These are basically ways of encoding a binary string or a binary piece of data into a string. Because typically, if you hand out codes to someone, those will be 32 character long strings that you can enter, but in the end it will just be binary information that will be compared and shifted, etc. So that's the way how you can issue codes to people. These are the functions that are in there. One is the secret type code. By default, we use the decode base 32, so we issue the secrets using base 32 encoding. You can also say how many digits do you want. Normally it's 6 by default, but you can also say I want to have 7 or 8 digit codes. So that's a choice. The standard allows you to use your own. What kind of encoding you want to use for this, and this is for creating the code, so you use some kind of encryption for that. The most used one is this one, SHA-1. So if you use, for example, the Google Authenticator app, it will only work with that code. The Microsoft code, I think, also. So most default to this one code, and we also set that one as the default for our application. Then there's the epoch setting you can use, so you can allow shifting dates. So you can say, okay, even though that somebody has my secret, we set the current time. We don't use the current time, but we use, for example, the current time minus 1 day or whatever. So you can still vary and make it more complicated if you would like to. The apps currently don't do that normally, but you can if you like. There's also a step size. So by default, the period code is valid is 30 seconds. You can make it a minute. You can make it shorter, longer, whatever you like. The default is 30. That's what most applications do. And this is a specific one for this the class that we did. We said, okay, we have a grace count of 2, which means you can be 2 periods ahead or 2 periods behind, and those codes are still considered to be valid. And then we have function called is valid time-based one code. So this function will just simply give true or false. Do you have a valid code? You pass it a secret. The secret is the password that both ends know. You pass it the code that has been typed in, and it will give you a true or false. That's as simple as it is. So you simply need to define a form where people can enter the code, and then you call this function together with the password, and that's how you make it work. Yeah, you can issue these time-based one-time password, long word, using URI. And this URI can be scanned or can be input in your application. So typically what you would do is create a secret on the fly. You want to create one secret per user, so each has their own secrets. Go with the defaults, like I say here, and in the bottom it says, okay, what does the URI typically look like? It says OTP auth, authentication, with this up front. We say it's the DF auth. This you can define yourself, guess the data flags, but you can give it a key for your user ID, etc. And the secret is this long string here. In this case, it's I think it's using the 256 algorithm. So if you use this SHA-1, it will be a shorter key that somebody can type in. So how do you get those to the people? Switch. That's still running. Typically, there's a function test here. You fill in the defaults. So you fill in what's the key. Well, this happens to be a perfect key for us, both in the use characters and length. But you can just generate a random key based on the settings here. So in the settings, I define I want to have a base 32 password to be generated. It's to be for 6 digits long. It should be using SHA-1 encryption. And this is all using the defaults. And then you can enter some defaults. These are just free to enter. It's information for the application. It doesn't do anything with it. It's not part of the encryption, etc. It's just information. And then in this function test, we put in just generate random passwords, and it will generate QR codes. So if you have a QR code, you should be able to scan it. Let's see if that goes OK. Let's click on a plus, zoom barcode. Oh, where did it go? Yep, there it is. I don't know if it works like this. Normally, Beamer is there. I can zoom it, take it from my own screen. I don't know. Oh, OK, thank you. Yeah. Screen. Let's press F11. So, there you go. OK, so now it works. So now it added it at the bottom. It says data flags 61, blah, blah, blah. And that's the information. So it's very easy to scan it using this QR code control. So you have the QR code. If you scan this one, I think this one is from the data flags app that we just have. You can just scan it with your phone, and it will just bring up a new Authenticator app in there. But that's the way, is how do you get the QR code to the people that are using it? You should have some kind of method for them to log in and say, okay, from now on, I want to use this two-factor authentication. Maybe you send them a link. If they click the link, that they have a QR code. They just need to scan it with their phone, and from that point on, they will be able to use those codes. Yeah, that's some things to think about. How to issue the secrets, how to reuse it. Do you want to reuse code, yes or no? Or do you say, okay, if somebody changes a device, can they rescan their current code? Probably not. Probably I would say, okay, if somebody changes a device or they lose their phone or lose an app, generate a new code. So always get a new QR code, they need to rescan it, and then they are good to go. So those are things that you need to think of. You could, for example, send a user an email message containing a unique link that if they click it, it will just show them the QR code, they can scan it. If you do it like that, then I would also at the same page ask for the current code. So once they've scanned it, it will show the code so they can enter it. So you know exactly for sure that they have the right code scanned and it belongs to them. And then you could store the generated secret. So it could be a randomly generated secret stored in the user record. So that whenever they log in, you ask for the user, you find the user in the database, you compare the password. Password is OK. You read the secret. If you have the secret, you can calculate the code, and you just compare the codes, and you know they're valid to go. If they're not, they don't have an ability to access the system. If they don't have the ability to access the system, you could create a link and say, okay, please send me a reset link to the email address, and then click on that link in the email and direct them again to the code. So to make this work with the QR code, there is a QR code control. It's very easy to use. It has a JavaScript part and it has a server part. On the DataFlex part, this is just what you need to do. You say use C web QR code, you give it a location and a size, and you just give it a value. And the value will just be transferred into the QR code dynamically. So you can use it not only for issuing code like this, but you could use it for anything. For generating a URL with the phone. So if it's the URL HTTP blah, 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 and you scan it with a normal QR scanner, it will directly go to that website, for example. So you can use it for multiple things than just this QR stuff. Okay. Questions about this? Nope. Code is available. Yeah, it's downloadable at the EU site. I think if you search for Authenticator, it will bring you the workspace, and you can use it. Yeah. Yeah. I got one more remark just to fill out with what Stephen just said. I would think it was an excellent explanation of the views and things, how to use views. But just from my experience, we had once a customer that was complaining. We uses the technique of using database views, and they had trouble. They said, okay, when we run it in our office, it runs perfectly. If we run it at the hospital, it depends on what we're looking for, it will run fast or not. To give you an idea what the view looked like, let's see, it's this. So this is what the view looks like, and it says select number of columns from a number of tables. And you see in the from, we're doing complicated stuff here. It's not only doing normal joins, inner joins, which is not complicated, but just joining, but we're also using outer apply to select the top one row, blah, blah, blah. You can imagine that for SQL Server even, you can make very complicated where clauses here. Typically, if you would access this from DataFlex and say clear the table and find greater than, or you move something into a key and say find greater than, you will, for example, you're looking in the customer table, you say, okay, move 1,000 to customer, find greater equal customer. You would expect to find it starting with row 1,000 or customer 1,000. If there's a lot of data behind it, and this is a view, and you're accessing it, what the SQL Server actually does, it's going to build dynamically the indexes. And it does that, and then it will just find the right record. The thing is, how fast can it do that? My point is, if you're using views like this and complicated things, you want to use SQL filters with it. Because if you already know that the SQL filter that, for example, it's only for customer number 1,000 that you need the data for, add a SQL filter that says, okay, customer number equals find 1,000. Because then SQL Server knows up front, with all the subqueries that it needs to do here, that it only needs to focus on those 1,000 range, and it will perform real fast. If you don't do that, and it's a very large database, you will have to wait, depending on, a very long time. So if you use views, complicated views, and there are no indexes behind it, I would recommend you to always include SQL indexes if you know upfront that you only need data for record number so much or between dates such and such. That gives the SQL Server the chance to optimize their queries, and it will work much faster. Okay, thank you.